Okay, so like as mentioned just now during the lesson, right? When we have a current flowing through a piece of wire, there will be a magnetic field generated. Okay, so in the previous lesson we have seen this before, right? Where I took a solenoid or a coil of wire like this, and I placed the compass inside it. So as you can see now, the compass, right, is pointing towards wherever is the north pole of Earth, which is happens to be in that direction. Okay, so as soon as I turn on the current, right, you can see that the compass immediately jumps and points in this direction here. Okay, and this happens because the wire, right, is carrying a current in a circular manner in this coil, and this generates a field that is pointing towards the is this the left or the right of the camera, or pointing towards the camera rather. Okay, and we can see that if you look at the battery direction, right, the current is actually being carried in this direction, over here, all the way this way, and around the coil this way. Okay, so if we use the right hand grip rule, right, we follow the curve, or rather the turning of the coil or the turning of the current using our fingers, and the thumb will give us the direction of the magnetic field inside this coil, right, as you can see this way. Okay, now the other thing that the other way that we can use the right hand grip rule is to swap the assignment of the current and magnetic field. Okay, so now instead of the current being represented by the fingers, is represented by the thumb, and the magnetic field, instead of being represented by thumb, is now represented by the fingers. Okay, so we can predict then that if we place a wire like this on top of the compass, right, if we place a wire on top of the compass like this, right, we know that if the current is flowing, as we saw just now, in this direction, okay, we can then apply the right hand grip rule like this. Okay, and we will see that there is going to be a magnetic field. If the current is flowing in this direction, there will be a magnetic field that will be wrapping around the wire in this way. Okay, so towards this side on top and towards this side below. Okay, so watch what happens to the compass once I switch the current on. Okay, current is switched on now. You see that there's a slight deflection towards this side, right? Switch off, and then it goes back to the normal north. Switch on, deflects again, right? So what happens if what happens if I place the compass on top of the wire now, right? So remember, current direction is towards here. I wrap around, so on top of the wire, the magnetic field should be pointing this way, right? Can you see? Pointing this way. Okay. So if I switch on the current, deflection towards that side. Okay. Okay. No, switch off, no deflection. Switch on, deflection. Okay. Now, the fact that the compass is not pointing all the way to that side, right, shows that the magnetic field, right, that's generated by this wire is not that strong. Okay, it's roughly of the same magnitude as the Earth's magnetic field, right? So that's why the resultant field that we get, right, is somewhere in between directly west and directly north. Okay, okay, Ken.